And welcome everybody. Welcome to our next Jumpstart event. This is Virtualizing Your Data Center with Hyper-V and System Center. I'm Simon Perryman, a Senior Technical Evangelist with Microsoft, and I'm joined by Matt McSpirit, a Senior Product Marketing Manager with Microsoft. And today, we're really going to go throughout the Microsoft stack, looking at all of our virtualization solutions, from core Hyper-V all the way up to System Center. Now, throughout the program, we're really going to try to cover a lot of different topics, really give you kind of a basic foundation, all the way up to advanced data center management using our System Center suite of utilities. As we take a look through the day, we're going to kind of focus on the basics first, deploying our hosts, configuring the storage, and the networking for them. We're then going to move on to high availability, explore how clustering can keep your virtual machines more resilient and highly available. We're then going to look at how we can configure different types of virtual machines, and then we're going to figure out how we can go and move them through different forms of live migration and replication. We're then really going to take a look at some of more private cloud-focused concepts, network virtualization, and using templates to deploy different types of services with standardization built in. We're going to continue this cloud focus towards the end, looking at how we build private clouds, and then looking at how System Center 2012 R2 can provide these end-to-end cloud capabilities, really focusing on how they're optimized for Hyper-V. As we wrap it up at the end of the day, we're going to look at how we can manage diverse virtualization infrastructures as well, taking a look at VMware, how we manage it, how we monitor it, and how we migrate between our different solutions. Well, I'll briefly introduce myself here. I'm a Senior Technical Evangelist with Microsoft. I've been at the company almost 7 years now, first as an engineer working as a program manager, and for about 3 years I've been in this role as a Technical Evangelist. And basically as a Technical Evangelist, and believe it or not, yes, that is my real title, I do get asked that a lot, we're basically out there to help our customers learn the technology, convince them to use it, and just become more efficient with it. Matt, why don't you go ahead and introduce yourself?
Yep, thanks Simon. Good morning, good afternoon, good evening, wherever you may be. My name's Matt McSpirit, and I'm one of our Senior Technical Product Managers. That is my title, unfortunately, as well. And I focus on the virtualization, the management of virtualization, all this stuff around that, and increasingly more storage, networking, and some of those key components. And I'm going to look forward to taking you through and guiding you through some of those key components today, along with Simon, obviously.
Thanks, Matt. So next thing we're going to talk about briefly is going through our actual lab environment. We want to make this extremely hands-on, extremely interactive. And at the end of the day, we're even going to tell you how you can actually go and do the exact same demos and exact same labs that we have. We've already hosted it, made it publicly available, but we're going to tease you throughout the rest of the day and not give you the link until the very end here. But again, every single demo, every single lab we're going to be doing, we're going to make available to you at the end of the day for you to try it yourself. Essentially, what we've built here is a pretty simple infrastructure. We have a pair of Hyper-V hosts. They're actually running Hyper-V Server 2012, and we'll explain why that's important shortly. We manage them using System Center Virtual Machine Manager as our primary management interface. That's what we're going to be connecting into. Now, we support remoting throughout all of our technologies, so we're actually going to use the same server, our VMM server, to manage our hosts, through failover clustering, through System Center Virtual Machine Manager, and through Hyper-V Manager. We also have a file server that's deployed, and we're going to be talking about how we can run our Hyper-V virtual machines on an SMB file server. So instead of having to put it on traditional SAN storage, you can just use a Windows file share and store your virtual machines on that. Then we have our traditional server, our domain controller, Active Directory, DNS, kind of those core functional roles. But with this basic environment, we're going to build out a very rich infrastructure for you, end-to-end, to show you how you can quickly adopt to the Microsoft stack. So let's first cover a brief introduction to Microsoft virtualization and kind of compare some of the key technologies we have. Now, very shortly, we're going to be adding a poll to the screen. And if you're in widescreen mode, could you please exit out of that, answer the poll? And the first question we want to know is, what is your virtualization experience? Are you exploring Hyper-V, VMware, Citrix, other types of hypervisors? So if you can answer this poll at the bottom of the screen, we'd love to get your feedback. Now, what we're really looking at here through our key technologies is, what does Microsoft do? What does VMware do? And kind of the key message here is we have an identical suite of technologies. We could do everything from basic hypervisor management to more advanced centralized virtual machine management with Virtual Machine Manager. As we kind of move up the stack and think about more cloud-like capabilities, we have self-service that we provide through App Controller, which is kind of similar to the vCloud Director. For monitoring, we use Operations Manager, which has the same or similar capabilities to the vCenter Operations Manager suite. For protection, backup, and recovery, we have Data Protection Manager, which is equal to our vSphere Data Protection. Service management includes Service Manager, similar to the vCloud Automation Center, and then finally, automation. We use an orchestrator. VMware has the vCenter orchestrator. As you can kind of see throughout these suite of products, pretty identical offerings across these companies. And a little later today, we're going to demo pretty much all of these as well for you. Now, the way we bundle these up is Microsoft sells this under the System Center 2012 R2 suite. You buy this single suite, a single license, you get all of these technologies here. We don't have separate licensing for just operations or just automation or just self-service. Again, a single license, you're going to get all of these technologies. Now, as you kind of look at some of the details on the licensing, and we won't spend too long on this, we try not to be marketing guys, right? Matt might have it in his title, but we try not to be marketing guys too much.
Thanks.
As you kind of look at this, there's definitely some price differentiators as well. And generally, we find in the industry, Microsoft is a little cheaper. Not just cheaper, but we even include a completely free hypervisor. So let's take a quick look at some of our deployment options here. Option number one is what you're probably most familiar with, traditional Windows Server. Go install the host operating system. Select whether you want to do a full installation, which gives you the rich graphical interface, or minimum installation, which actually cuts all of that GUI, cuts out Internet Explorer, kind of the unnecessary pieces. And this gives you actually more security options as well. If you have an operating system without the GUI, without Internet Explorer, there's a smaller attack surface. It's a smaller OS footprint. You get the benefits of having fewer patches you need to install, which means fewer reboots, which actually means higher availability. So if a GUI really doesn't matter to you, go ahead and install the base installation, Server Core Edition, and you can still remotely manage it, get that full, rich graphical user interface, yet have the benefit of fewer patches. Now, when you go and install it, there's lots of other roles that are included with Hyper-V as well. But the best practice with Hyper-V hosts is to keep it a dedicated virtualization host. Oftentimes, you're actually going to design the physical hardware for a Hyper-V host to be really focused for virtualization. Lots of memory, lots of networking I/O, lots of storage I/O. And the way you actually architect that physical server may be different from other servers in your environment. We also want to make sure that your Hyper-V hosts aren't being overwhelmed by other types of requests, other types of workloads. So we really want to encourage this best practice of keeping the Hyper-V host dedicated just to Hyper-V. Now, the next deployment option is actually a different SKU we offer. This is known as the Hyper-V Server SKU, and this is completely free. I'll repeat that, 100% free. Go to download.microsoft.com, get it today. So, what is included in this? Well, it is basically a Hyper-V host. There's no graphical user interface. There's no Active Directory. There's no file server. But you get every Hyper-V feature, the full storage stack, the full networking stack, as well as all of the clustering features as well. So this essentially gives you the ability to get a free host. Whatever you want to run inside your virtual machines is a different licensing consideration, but you can certainly run Linux VMs, or if you have an enterprise license with Microsoft, use those licenses up in the guest operating systems and really try to reduce the entire cost of your infrastructure. You're literally being able to get your host for free. And again, you still get to manage everything remotely through Hyper-V Server, Virtual Machine Manager, or even through a set of client tools that you can run on your laptop, known as Remote Server Administration Tools. Bottom line is, regardless of whether you choose the full installation, the Server Core installation, or the Hyper-V Server installation, you get the exact same suite of features. So we want to make sure that you understand what we can do across the board, regardless of what type of installation option you're using. Now, let's take a quick history trip here. A lot of people don't realize how mature Hyper-V actually is. We actually first introduced it back in 2008, 6 years ago now. We've continued to improve with each of our releases, adding new features, really trying to become enterprise ready when we started to introduce things like live migration, distributed access storage through cluster shared volumes. With our most recent release, the SP1 release, we added what we call dynamic memory. Dynamic memory gives us the ability to over-allocate memory to our particular host. I will spend a little bit of time later explaining how that works. In 2012, we introduced the first part of our big release here, which is Hyper-V for 2012. A lot of new enhancements built in here. And in many cases, Microsoft and Hyper-V actually released these new features to market first. A lot of these are innovative features that came from Microsoft, such as the Hyper-V replica, which have since been replicated by other vendors throughout the industry. So after the quick history tour, we're just going to spend a few minutes talking about some of the key scalability considerations. What we're pretty proud of with Hyper-V is it supports the highest scale numbers in the industry. We support 320 logical processors per host, up to 4 terabytes of physical memory per host, 1,000 virtual machines a host. And when we start to add clusters, we can really scale up even larger, 64 node clusters with over 8,000 VMs per cluster. But when you think about the boundaries of high availability for your VMs, we can even live migrate from one cluster to another cluster. So while we say that you're kind of limited at 64 nodes in a cluster, the fact that you have this extended mobility really allows you to scale out and make your entire data center highly available and do failover even between different clusters. When we look at our virtual machines, we support 64 processors for the VMs, 1 terabyte of memory for each VM. And Matt and I were regularly out speaking to customers. We always ask, does anybody not meet the scale needs? And there's maybe 1 in 100. We hear these crazy high-end applications, usually from the government. We ask them what it is, and they say, if we told you, we'd have to kill you. So we don't even know what they're trying to run there. But we're pretty confident that you're going to be covered for most of your key enterprise applications as well. So let's take a quick look at how we kind of stack up to VMware. And you can see across the board, pretty equivalent. Some cases, we have a few extra enhancements, such as our cluster support here. But more or less, if you're looking at scale, either virtualization solution is going to be able to scale to your needs. So kind of look beyond, these basic checkboxes. Think about other features, other capabilities as you compare these different hypervisors.
I think it's important to point out there as well that that particular table, whilst it lists in the left-hand column Windows Server 2012 R2 Hyper-V, it's as applicable to that Hyper-V server SKU that Simon talked about
earlier. The free one, right?
The free one, correct, as it is Windows Server with Hyper-V. So whether you deploy Hyper-V Server, Windows Server 2012 R2 Standard and enable the Hyper-V role, or Data Center, all of those statistics in that table are the same. And the beauty of that is, for instance, if you do have a need for 64 virtual procs in a VM, which, as Simon said, is a relatively small number of people, but it happens, they're not forced to go to a specific top-end SKU to take advantage of that. They can even use the free one. So that's pretty useful. It's across the board. All of those features and capabilities are available.
And I mean, to kind of emphasize that, as you're scaling up and adding more and more bigger and bigger applications, you can just keep that same host, right? Because again, the free version supports even those larger scale numbers.
Yep, all of the features.
Don't need
everything.
it today, you can still get it.
Yep.
Use that same host. No need to upgrade your licensing or installation. Use that exact same version. Well, now we're going to kind of go to a slightly higher level and talk in general about how we manage our virtual machines. So under VM management, we're really trying to position System Center Virtual Machine Manager as kind of our centralized management concept. Now, when you think about managing an individual Hyper-V host, oftentimes you go onto the first host, configure it, do it again on the second host. Maybe you write a PowerShell script so you can repeat that. But as you start to scale up and manage dozens of hosts, you really want to think about just having a central management unit. Not just to ensure you have consistency, but also because it has automated features built in, automated deployments, automated patching. So as you're really managing more of these servers, you want to think about how can I simplify my management? How can I streamline? And we recommend using System Center Virtual Machine Manager. Using the single console, it basically allows you to aggregate all of your different hosts and your clusters and key infrastructure servers that it needs to interact with, such as your Windows Server Update services, so you can download patches and deploy them to your hosts. It integrates with our Pixie servers, so you can go and do boot from VHD or bare metal installations on a brand new host. And we also support third-party hypervisors as well. So if you already have VMware or Citrix in your environment, you can manage those existing virtualization investments, plus Microsoft Hyper-V using, again, that single management console. So we're really trying to be heterogeneous. And as you see later, we can even go and extend Virtual Machine Manager to the cloud by using App Controller, allowing us to move virtual machines from our on-premise hosts up to Windows Azure. So a lot of end-to-end capabilities built in with this technology. Now, let's take a quick look at the Virtual Machine Manager architecture. Basically, what we're really looking at here is our centralized management server. This is basically the brains of the operation. It keeps track of all of the hosts, all of the different policies that you have, where different resources should reside. We go and connect to that central management server using what we call the management console. This can be configured remotely on a different computer, so the management server, the brain, is different from this management console, which are kind of like the eyes, that what we go and interact through. Now, all of the System Center 2012 R2 components require SQL Server as their database, but don't worry, we give you SQL Server as part of your System Center license. But this allows us to have things such as high availability and take advantage of SQL reporting services when we want to go and get richer information out of our database. We then have what we call our library that allows us to aggregate and store resources that we're going to reuse again and again. So standardization is going to be an important concept as you start to think about large-scale virtualization. When you go and deploy a VM or a service or an application, you don't want to go through the manual steps of configuring it each and every time. We're proposing and encouraging people to use the best practice of build a template, make it correct the first time, standardize, and then each subsequent deployment will be faster, it will be guaranteed to be consistent, and you're going to spend less time doing troubleshooting for misconfigurations. So using our library, the centralized collection of resources, is going to help with your reusability and help provide better service uptime. And then the final piece of our architecture are the individual hosts themselves. We support up to 1,000 Hyper-V hosts for each management server, and of course you can deploy multiple management servers as you scale up and manage even more hosts. But as we think about the architecture, we also want to think about keeping that architecture highly available as well. If we're using Virtual Machine Manager as kind of the brain for our infrastructure, we want to make sure that that brain stays healthy and a crash doesn't impact that single management system. So as we look about high availability architecture, we can actually install our management server on a failover cluster. So if the management server's physical server crashes, that management server will fail over to a different host, resume, and continue performing the same operations. You also have the ability to virtualize any of the System Center components inside a VM and have that VM running on a cluster. So the VM can restart, the VM can move around to different locations. Now for our SQL Server databases, we support SQL clustering, SQL HA, SQL Always On, so you can ensure that those databases are highly available. They can be resilient, and if you even have them at multiple geographic locations, you could set up database mirroring and log shipping to ensure consistency, high availability in the event of a site-wide disaster. For our management portals, we can use network load balancing to distribute the access points so a particular website doesn't get overloaded. And then our library server can also be made highly available, put on a cluster. If one of the hosts that gives us access to the library is unavailable, that access point simply fails over, and we can continue accessing all of our library resources. So we've really tried to design high availability throughout the stack here. As we continue to expand with System Center, think about these other components. We're going to first introduce App Controller. So App Controller is essentially our self-service portal for infrastructure provisioning. App Controller has a dependency on Virtual Machine Manager, and it's basically a website that allows you to view a limited scope of what Virtual Machine Manager offers. So for example, I might have a SQL database administrator in my environment. He wants to go and deploy some SQL virtual machines, but I don't want him messing around with my infrastructure. I want to hide the underlying clusters, the underlying virtual networks, the underlying storage topology, and simply say, you have a cloud that you placed it in, you have capacity, just click deploy. And self-service, we're really trying to make that simple. Think of it like going to a restaurant, looking at a menu. You have 8 options. I want this option. Go. That's the type of end-user experience we're really trying to empower with our self-service capabilities. The next key component that we're going to be discussing is Operations Manager. We use this for real-time monitoring, and we monitor from the mantle all the way up to the app, so we can monitor the health of our hardware, our hypervisors, our physical servers, our virtual machines, applications running within the virtual machine. to provide any type of performance alerts, availability alerts, or service interruption alerts. We then are going to be discussing Service Manager. System Center Service Manager is the back end to one of our self-service portals, and it's also our ITSM help desk. So if you're doing traditional incident management, problem management, or you want to manage requests from end users about their virtual machines, hey, my VM's performing slow, give me more capacity, you can use this self-service portal, this utility, to support that. System Center Orchestrator is our automation engine. Using a graphical interface, we could go and connect diverse systems, and we can simplify scripting. We simply use different icons, connect the dots, and this creates what we call a workflow that can be triggered manually, based on time, or automatically based on different system events, such as an alert coming from Operations Manager. And then last but not least is Data Protection Manager, allowing us the ability to back up our virtual machines, our hosts, our System Center infrastructure, our databases, pretty much any Windows component running in your data center. Also, you get to back it up during live migration, back it up with no downtime to the VM or the running application. So that kind of gave us a quick introduction of the basics of Microsoft virtualization. Matt, I'm going to turn it over to you. You're going to start to discuss our host management, right?
Yep. Well, host configuration, host management. So for the next 7 hours, is it roughly? No.
It's not that long. Hang in there, guys.
Yeah, we've got a fair amount of host config to cover. The key thing with getting that host configuration right and understanding the different options is it gives you that solid foundation to deploy some of the VMs, some of the services you want to deploy on top, and also gives you that strong management platform as well, as Simon has alluded to. So for me, I'm really going to start with focusing on how we can get Hyper-V deployed. Now, many of you, if you're working with smaller environments, you may say, well, I'm just going to pull down the ISO from my licensing site, or if you're using TechNet or MSDN to grab your, or an eval even, download the ISO, pop it on a DVD, and then deploy. Or you can use a virtual console type approach if you're using something like a lights out type deployment, attaching the virtual disk over to the machine you're looking to image. That's up to you, but you're starting with that DVD or that ISO image. Fairly traditional, but not really scalable, certainly if you're doing a lot of different hosts. An alternative is deploy from USB. Doesn't really change the scale in any way, but it's another option if you've not got perhaps a DVD drive in that particular device you're looking to image. Obviously, if you're trying Hyper-V on modern laptops, they may not have a DVD drive built in, so using a USB disk gives you that flexibility. Now, this is deploying from a USB disk, not specifically to a USB disk. Okay, so that's important with Windows Server 2012 R2. We can deploy from, so using the USB disk in place of a DVD or ISO, but not actually deploying to the actual DVD, the actual USB disk itself inside, for instance, a chassis. That's not something that Hyper-V and Windows Server 2012 R2 support specifically. But then a final option, and Simon alluded to some of this stuff before, is around getting it across the network in a more scalable, centralized fashion. And that's where you could use something as simple as a Windows deployment server, a WDS server, as some people may know it. You may know it in historical terms as RIS, so Remote Installation Services. And what we've got there with the ability to do network deployment is it literally does send across the network using multicast, if you've got that capability enabled, to image a large number of machines simultaneously, at scale, enabling you to standardize that deployment of all of your Hyper-V hosts across the network. Now, as I've said, I could use the WDS functionality of Windows Server, so a role. I could increment that with something called the Microsoft Deployment Toolkit, which is a free solution which gives me a little bit more granularity in terms of deployment. Or alternatively, I could use something like Virtual Machine Manager, as Simon alluded to earlier. Because with VMM, we've got a built-in solution that harnesses that WDS engine, that Windows Deployment Services engine, as the mechanism to push the image over the network. But it uses that engine combined with its management knowledge to help you customize and build an image for Hyper-V to then deploy across the network. And it does it in a really intelligent way. Now, what we have on the slide here is something we call deep discovery prior to actually deploying the machine. So imagine you've got a scenario where you've just taken delivery of a bare metal machine with nothing on it whatsoever. It's completely blank, or perhaps you've just shut down an existing machine that you want to re-image. Either way, this machine is in an off state. Now, through integration with what we call the baseboard management controller, the BMC, we're able to actually wake that physical server up, So this isn't necessarily your network connected into your regular NICs on this bare metal server. This is a specific port, usually has a little wrench or a spanner icon that you've plugged into, maybe slightly lower network speed, usually 100 meg typically. It's that port that we're talking about here that you may have IP addressed on a specific subnet, or you may have used DHCP. Either way, we're communicating with that port, so you really need to know the address of that for when VMM scans to discover that particular host. And through deep discovery, it's going to wake it up, so do an out-of-band reboot. It's going to trigger that particular machine, that bare metal server, to boot against the WDS server, so PXE boot. Now, in our environment that we're going to see shortly, our WDS and everything is on the same server as the VMM, but in production environments, that may not be the case. VMM and WDS are going to have some conversations and going to authorize this particular host. It's going to be, well, did you tell this server to boot and ask to PXE boot? VMM's going to say, yep, that's the one I'm working with at the moment. It's going to download, so the bare metal server is going to have pushed to it a WinPE image that you would, if you're familiar with Windows deployment in recent years, so 2008, Windows 7, etc., you'll be used to WinPE. But this is a VMM customized WinPE that as soon as it boots, it's going to execute a set of calls that is going to inventory this particular server and return that back to VMM's wizard. Now, that particular deep discovery may take a few minutes. Some of these servers take a little while to boot up from scratch if they're doing a memory check, for instance. But either way, what's coming back to VMM is a set of information about that inventory, disks, network cards, and so on, which allow you to proceed through the wizard to actually then say, okay, what do I want to configure this server to look like? I've got my base image contained within VMM's library. So you'll see in the library here, we've got what's called a physical computer profile on the slide there. We've got some drivers. So maybe I'm using HP or Dell or IBM servers or whoever it may be. You've imported their appropriate drivers, many of which will come from Windows Update anyway. But if you've got some specific drivers and utilities, you can bring those into VMM and use things like PnP ID matching. And you've got what's known as a virtual hard disk as well. And you say, well, I thought virtual hard disks were really about VMs. You know, a VM has a virtual hard disk. Why are we looking at this from a bare metal perspective? Well, as Simon rightly called out before, we've got boot from virtual disk, boot from VHD or VHDX, which means when we're actually using VMM to image a system, we're pushing down a virtual disk, a VHD or VHDX file, down to the target physical system and configuring the boot configuration data store to boot from that virtual disk. So it's incredibly clever the way it does it, but it will deploy that Hyper-V image, it'll reboot that machine again. So having done the deep discovery, VMM's going to re-wake up, if that's the correct term, it's going to wake up that particular bare metal server again, boot from PXE again, authorize, customized WinPE image will be pushed down, but this time that WinPE image is going to trigger the actual deployment. It's going to run any commands, scripts, configure any partitions that you configure in VMM, and it's going to push across that virtual disk and configure the drivers. Then as part of the final wrapping up process, once that image has been deployed to that Hyper-V host, VMM's going to trigger joining that machine, that bare metal host to the domain, bringing it into VMM's management ready to deploy virtual machines. Now, if I pop over to my little demo environment very quickly, just to give you a heads up of what the physical computer profile looks like, you'll see on the screen here we've got Hyper-V. We've got a physical computer profile. We're inside VMM, and don't worry, we're going to spend a lot more time in VMM throughout the course of the day. But I'm looking in the library. As Simon said, it's a repository for storing stuff, ISOs, virtual disks, PowerShell scripts, in this case, profiles and templates as well. And I'm looking at a physical computer profile. If I bring up the properties of this particular profile, we'll see it's only got a few settings: name, what's it going to do? So it's going to actually turn this into a Hyper-V host, virtual machine host. The virtual disk file, that's the image that is going to be pushed from VMM's library down to that bare metal server. The hardware config, I'm going to configure all of the network settings of this particular target host, the disk partitions, the driver filtering, any OS configuration. It's going to join the domain, it's going to have a certain password, it's going to have a product key if necessary. And if you are using traditional answer files, sysprep, unattend.xml in this case, I can attach those as well and use those as part of this deployment to do some fine-tuning of the OS upon deployment time, and any run once commands that I want to add. And finally, any host settings. I may not know these at this point, but if you've got a standard path that you'd store virtual machines on once you've got a Hyper-V host under management, you can configure that here as well. So all of that is within my physical computer profile that I specify when I choose to do and perform a physical deployment using VMM. And that's one way of scaling out deployment, because don't forget, all VMM's functionality can be exposed through PowerShell. So when I get to the end of a wizard, I can take the PowerShell script, adjust and modify to meet my needs, and start to scale that out in an automated way. When we think about how we compare with VMware on this deployment front, we both deploy from DVD or ISO files, USB. Obviously, VMware has got a slight advantage in certain circumstances where you can actually deploy to a USB stick or even an SD card within a physical chassis, which is great for some people, not great for others. If the resilience of a USB stick, perhaps if there's only one in a chassis, it's a single point of failure, I suppose. But when we come to network deployment, as we said, for a stateful deployment, i.e. it gets deployed down to the metal and you can disconnect from the network once that's finished, and the image will still continue to run and the actual OS will continue to function. That stateful deployment can use WDS for the deployment, MDT, could use Configuration Manager, but we've talked mostly about VMM.
Now, Matt, we had a couple questions come up about USB here. We've mentioned accessing USB. Could you maybe just spend a minute and say, what can we do with USB as far as booting from it, running Hyper-V off it?
Yeah, so the main premise with the USB is I would download an ISO. If let's say I was doing an evaluation, I would download an ISO, I would extract the files from that ISO, and I would create a bootable USB, copy those ISO files onto the USB, so not as an ISO, but the files from within the ISO, copy them onto a USB stick, plug it into my server, boot it, and install to the hard drives from the USB stick. I can't put that USB stick inside a chassis on the motherboard in a special internal USB slot and run Hyper-V there. It's not supported. Okay, maybe that certain OEMs are shipping that with Hyper-V server, but it's a minimal few.
Okay, yeah, great clarification.
Typically the full installation with Hyper-V.
Now we do have another kind of card around the deployment here. What about using SD cards? Can we deploy to an SD card?
No, not supported.
Okay.
No. Okay, so that kind of summarizes some of the key capabilities around deployment. But when we think about host config, VMM, let me take a step back. When we find customers and smaller organizations using Hyper-V, they tend to, as Simon said, use the interfaces that are available within Hyper-V, like Hyper-V Manager and so on. But more and more organizations look into VMM to provide that centralized host configuration. And that's where VMM can help me understand the status of my hosts, the hardware-specific settings, the BMC settings, the network card settings, and so on. It allows me to configure all of this on a host-by-host basis. Storage, so attaching the virtualization host, the Hyper-V host, to iSCSI or Fiber Channel storage, or even SMB-based storage, as we'll see throughout the demo as we go forward. Configuring vSwitches, big piece of advice from my perspective. If you're starting off with a fresh Hyper-V environment and you're intending to use Virtual Machine Manager, use VMM to create, provision, and deploy your virtual networking. You can obviously use Hyper-V Manager to configure much of this stuff and then import that into VMM, but VMM really likes it if it's able to deploy and configure and manage all of that itself. So if you're inheriting a Hyper-V environment and putting VMM over the top, that's fine, but my advice would be to use VMM to deploy and configure much of this if you can. And that's where we'll focus when we start to look at some of the demos later on. So virtual switches, being able to actually deploy and connect VMs through the physical ports out to the network. And migration settings as well. So enabling me to say, okay, this particular Hyper-V host, it's going to live migrate on a certain network. It's going to use Kerberos for authentication. It's going to use certain IP subnets for migration. And how many simultaneous migrations can we do at once? We'll investigate more of those settings later on as well, so don't worry. So that's a bit about host config. But when we think about hosts and storage, we need to get that foundation sorted. So imagine this scenario, we've now deployed our Hyper-V host using VMM, using that bare metal approach before. But how do we actually start to connect it to storage? And what storage does Hyper-V support for running your VMs? Well, we could use iSCSI or Fiber Channel, so let's call them traditional storage that a lot of people are using within their VMware environments, within their virtualized environments. So iSCSI and Fiber Channel still very popular. It's important to make sure that the connections to those arrays are resilient, and that's where multipathing is a big advantage. So rather than team your iSCSI NICs, for instance, leave them separate and use multipath I/O, which is enabled as a feature of Windows Server. And actually, a little tip of the day, the first tip of the day, if you're using VMM to deploy that Hyper-V host with that bare metal example that I talked about before, if you use that, VMM will actually turn on MPIO for you as part of that deployment, which I think is pretty neat because it can take a little, finding it in Server Manager, you're going into roles and features, turn on MPIO. It's a few extra steps that VMM's saving you the time to do that if you use VMM to deploy. But what that gives us is resilient connectivity across multiple paths from host to storage, and that's applicable to iSCSI and fiber channel storage. Now, the beauty of the Microsoft solution is you can use our framework, which is in box with Windows Server 2012 R2 and Hyper-V Server 2012 R2, or you can complement that with your storage vendor-specific add-ons. They're what are called device-specific modules. So, for instance, I could go to my storage vendor and say, I need your DSM to optimize my multipath configuration for my Windows servers. They'll give you it, it'll be an installer. You'll typically install it on each of your Hyper-V hosts, and that way you've then optimized it in respect of that specific storage array. Because our configuration will be generic, whether you're using an iSCSI or fiber, no matter what vendor. Get the vendor's DSM and utilize that to optimize the connection. And if you're using SAN, you can also take advantage of some of the new features that were introduced in 2012 Hyper-V and Windows Server. One of those is called offloaded data transfer. So imagine the scenario that you've got an operation that might involve moving data from one area of the SAN to the other.
Could that be like a VM deployment type?
Could be a VM
scenario?
deployment, a VM migration, could be a big file copy between a couple of VMs within that are both hosted on the SAN. Because at the end of the day, what you're doing is moving data from, at the block level, from somewhere on the SAN to somewhere else on the SAN. Now, if you've not got what's called offloaded data transfer, or ODX, that copy might use the network to copy those files around, and it might use valuable CPU and memory resources. Whereas in reality, all we're doing is telling the SAN, move the files from there on your LUN number 1 to there on LUN number 2. You know, Mr. SAN, exactly where all that stuff is. You handle it. And that's what offloaded data transfer. We're offloading the data transfer to the array.
And in some cases, if you're not actually doing a full copy of the data, you're just reallocating which arrays it's actually located in. We can just update the pointers. We're not even doing copies within the array itself. We're just updating file location.
Yeah.
So you could do file copies sometimes in a matter of seconds.
Yeah, incredibly quick. And the benefit of that as well is not only is it faster, but it means that we're not using the valuable CPU and memory resources from a host to handle that transfer.
Now, I think one important thing to mention, though, is the hardware does need to be ODX capable.
Yep.
So as you are thinking about, your next storage acquisition, try to make sure it supports that feature. You're really going to find a lot of benefits just simplifying things, speeding things up.
Correct, yeah, that's important. What we found in our lab, we had some different arrays that we tested the functionality on, and we found that some of the older firmware of these arrays didn't quite have the capability. Update the firmware to the more modern releases, or the most modern if you can, and you'll see that these features get exposed. It may be that certain storage vendors require some kind of agent on the host, or some kind of integration toolkit, if you will, but that's not applicable to all, and so check with your storage vendor. And the final thing to talk about from a storage perspective, and just the sheer disk support, is Hyper-V support of this next generation 4K disks, bringing increased capacity, better reliability, better density. So Hyper-V understands those straight away. Hyper-V and Windows Server 2012 and R2, it was engineered with this in mind to help ensure that it's future-proof when people are looking to invest and embrace those. That's just a brief glimpse into what Hyper-V supports for running VMs and the kind of things you can take advantage of. When it comes to Virtual Machine Manager, and remember, we always want to have that hat on of VMM being able to manage this storage stuff. VMM can actually centrally manage and provision all of our storage, including fiber channel SANs, iSCSI SANs, the LUNs, the disk volumes, virtual disks. It supports iSCSI and block fiber channel block-based storage as a mechanism to manage that from that perspective. And also, new in more recent releases of VMM, it enables you to manage and provision file server storage, and we'll see this shortly through demonstration when we take a look at the lab. It also integrates with these devices through a number of different mechanisms. So SMIS, SMP, two standards-based options that we're pushing into the industry and working with our storage vendors to build and enhance so that VMM can talk a common language with your array, which means it can provision new LUNs, it can understand the kind of features and capabilities that your LUNs have and take advantage of those, things like snapshotting, cloning, and so on. It can manage not only the devices, but the volumes, so create LUNs and present those out to Hyper-V hosts, and manage the HBA side of things. So if you've got fiber channel HBAs, it can start to help with some of the configuration there as well. And with R2, we made significant improvements for VMM in terms of scanning and enumerating the storage when you're bringing it under management, which streamlines the experience considerably.
You know, for me, another big advantage that I've seen customers have is some avoidance of vendor lock-in.
Yep.
You know, by kind of adding this consistent management interface, it doesn't matter if you have Dell, HP, Fujitsu, NEC as that underlying array. You kind of get a consistent experience of how you want to go carve up that LAN, deploy a LAN, manage it, deploy virtual machines to it.
Yep.
So, you know, if you've traditionally just used one vendor, you can start to have more flexibility. Yes, you kind of need to learn the new System Center interface to manage it, but once you learn that, pretty straightforward to use, doesn't matter that underlying storage array. So ultimately, should give you more flexibility, hopefully drive down costs as well.
Yeah, so if we flick through some of the screens here, SAN, we're looking at the provider, so integrating with VMM. We can choose a file server, SMP provider, SMAS, so remember these are standards-based. We've got a couple of options. We scan, in this case it's a Dell EcoLogic, that it's found based on the scan. We'll bring in that particular provider and its information, the model, the capacity, and then we'll start to be able to bring in and classify the individual storage LUNs, the repositories within that particular array. And we'll see a bit more of this later through demonstration. Now, for those of you who perhaps don't have an iSCSI SAN or you want to just try this out, if you download Windows Server 2012 R2 Eval, you can actually enable the iSCSI target functionality. It's a capability that's built into Windows Server 2012 R2. It used to be exclusive to Storage Server, and then we made the iSCSI bits available separately. Now it's in the box. So it's an integrated role. It's great for certain scenarios, and great for production, great for test and lab deployments, storage, and heterogeneous storage development and so on. It supports the key capabilities that we've introduced in 2012 and R2, like big virtual disks, thin provisioning, dynamic disks, differencing disks, and so on. It's scalable from a number of sessions you can connect, and the key thing, the last bullet point that we want to really call out, is I can manage it through VMM. So if you are looking to experience VMM iSCSI target management and just see what that experience looks like, you can manage it through the SMIS provider that's part of that. As you can see in the wizard on the right-hand side, I specify the protocol, in this case SMIS WMI, type the address or the IP address or fully qualified domain name of the iSCSI target. I was originally my naming the port and run as account, and then it will do the same kind of thing we saw before, gather the information, specify any LUNs of which you can classify, and we'll look at classification later on, so don't worry if that doesn't make sense at this point, and then bring them into VMM's management. And from that point forward, we can then provision new LUNs with VMM. Now, we've looked at iSCSI and Fibre Channel briefly, but VMM, as I said, will connect iSCSI hosts, your iSCSI SAN, to your host and log them on, so it will handle that process for you. So rather than going to each host and connecting through the iSCSI initiator to your iSCSI target, VMM can handle all that for you as well. And when it comes to Fibre Channel, VMM will handle the zone management, the member management, the zone set management, bring those ports in and allow you to unmask those respective LUNs to those target Hyper-V hosts. And once it's connected, VMM will enable you to create and assign LUNs, initialize the disk, partitions and volumes. So it is really taking on a lot of that storage management capability centrally in conjunction with your Hyper-V host management, which is really powerful. Not only can it add capacity, but it can also remove capacity, get rid of those volumes, mask the LUNs again in a Fibre Channel world. So pretty comprehensive storage management, but there's always going to be occasion when you will need to go back to your interface that's specific to your storage vendor's infrastructure. There might be some configuration or tweak that needs to be made at a more granular level than VMM has got available to it. So that's traditional storage. But what about if we think about exploding a SAN? It may not be something you've done in your environment. It may be something that's happened unnaturally. But if we deconstructed that SAN and ripped the lid off that particular SAN and had a look inside, what are we likely to find? Disks, maybe hard disk drives, SSDs, maybe a mix. And these are typically providing the raw capacity, and they're pooled by the controllers within that environment. And the controllers within that SAN, typically most production arrays have more than one for resilience and obviously maintenance when it flicks over from one to the other in an active-passive type scenario. But if you looked at what a controller typically is within the SAN, x86 processor, it's got memory, it's got some kind of bespoke operating system, typically that's the storage vendor's secret sauce that provides their magic. And this effectively controls what features the SAN has. Thin provisioning, deduplication, tiering, and as we said, those controllers, multiple controllers, provide the resiliency. And then you have some adapters. You need to be able to connect your hosts, whether they're Hyper-V, vSphere, or just regular Windows or Linux servers. You need to be able to connect them to the storage array. And that may be in the form of an iSCSI NIC, a regular NIC, fiber channel FCOE, NFS and SMB for file-based or network-based storage. All different options you could utilize. Some storage vendors have solutions that have multiple. Some you have to choose specifically, that this is a fiber channel array. It will only support fiber channel. Now, if you think about that, that covers, and there's going to be SANs that are slightly different, but for the most part, that's pretty much what a SAN is for a lot of organizations.
So how is Microsoft handling storage management? How are we kind of drawing these similarities to what a traditional SAN looks like?
Let's take a look. So from a Microsoft standpoint, if we think about physical disks, we're talking about low cost, low complexity JBOD storage. So a shelf of disks with very little intelligence themselves, with hard disk drives, SSDs mixed potentially, depending on what your options and your scenario, with SAS connectivity. Now, these multiple SAS connectivity ports connect to controllers. Now, in the Microsoft world, these controllers are Windows Server 2012 R2 file servers in a clustered scenario, which would form what we call a scale-out file server. Now, a scale-out file server has a couple of benefits. Number one, you can scale out the capacity by adding additional disk shelves. Number two, you can scale out the demand or the ability to handle more demand by adding more controllers. We support up to 8 cluster nodes in a scale-out file server. So that allows you to scale out from a management of handling capacity perspective. And these controllers, these file servers, create the disk pools, so they aggregate these disk pools, slice them into storage spaces, and we'll explore spaces in a minute in a bit more detail. And these can be thin provisioned, deduplicated, and they can be simple, mirrored, or have parity for different levels of resilience. And then your connectivity adapters, well, it could be gigabit, 10 gigabit network adapters, for support for SMB protocols for network-based storage. Alternatively, you could use specialized RDMA-capable network adapters, which can accelerate performance for 40, 56 gig. I think even 100 gig is on the horizon very soon, if not already available, which is phenomenally fast performance for connectivity to your storage. A little bit more expensive, but if you need 100 gig speed for your storage performance, I guess it's going to pay for itself. But there are your options, and notice the similarity between the Microsoft storage solution and what is essentially the internals of a SAN. But we're building it through Microsoft technology using low-cost, high-volume hardware. When we think about Hyper-V host storage support, we touched on a few traditional ones before, but storage spaces. We'll explain what this is in a bit more detail here, but this is essentially transforming those physical underlying disks, those raw disks from the JBOD, transforming them into pools, and then slicing them into spaces that we can then apply a volume with NTFS and drop virtual machines onto. We've now introduced tiered storage in Windows Server 2012 R2. So in the past, in 2012, when we introduced spaces, a space could only contain one type of disk. Either it was based on an SSD platform, or it was using regular spinning disks, and your performance would differ therewith. But with tiering, we're able to aggregate into a single pool mixed disks, hard disk drives, SSDs, and then when we create a space, which we'll see in a demonstration shortly, we're able to actually carve that space with tiering enabled, which means the hot blocks of data are automatically moved around to increase performance across that tier. We support deduplication, which is now supported for live VDI virtual disks, which can significantly increase your capacity by reclaiming duplicated space and blocks, but also at the same time it can increase performance for VDI. We've seen significant improvements in boot time, especially when using VDI with data deduplication. But at this stage, we don't support deduplication with server workloads at this point, and that's down to, for the most part, testing and performance testing. So we may see that improve in the future, but as of today, it's supported only with VDI workloads, running VDI workloads. Obviously, you can deduplicate offline workloads, library, templates, all of that cool stuff can benefit significantly from dedupe as well. And as we said, we could connect Hyper-V to iSCSI or fiber channel storage, but alternatively, we could connect Hyper-V host over the network to file shares using SMB 3.0, which has got incredible performance, easy to provision, as we'll see through a demo shortly, All of that cool stuff is available with Hyper-V and using Windows Server 2012 R2 as the backend. So Hyper-V host connects to file servers. File servers are using storage spaces and the tiering and the improvements in performance there to host your virtual machines. And provisioning is just so easy. I'm going to drop a VM on / file share 001. Doesn't get any easier than that.
Yeah, I think, there's still been kind of a couple questions, like what exactly is SMB? So basically, SMB is the server message block protocol that Microsoft uses to communicate with file servers. So you know how you set up the traditional file server, as Matt said, whack, whack, my share? If you kind of think about what that is, it's remote accessible shared storage, right? You can access that file share from one server from a different server. And so we've essentially made that just a simplified version of shared storage. Put your virtual hard disks in that share, connect to it from any host, and that's where your VM runs from. So just think about running your VM in a file share as kind of a simplified way to cover SMB.
SMB is the protocol, and it's been enhanced. That's why it's 3.0 now. It was released in 2012, it improved slightly in 2012 R2. So SMB as the protocol is delivering that traffic, that enhanced traffic, that increased performance. And if we look at using storage spaces as the backend for that, we can see from the slide here that again, to simplify what storage spaces is and what it's made up of, we've taken raw DAS disks. So these aren't iSCSI disks or SAN disks that were presented to Windows Server and we can use storage spaces with that. That's not the case. It's direct attached storage either in the chassis itself or directly connected via SAS. We take those raw DAS disks, we pool them, we slice them into spaces, and then we provision with a volume, or we add a file share, whatever it may be. And that fundamentally is storage spaces. And that tiering that we talked about, as I said, the pool of disks can consist now of SSDs and hard disk drives, and when we create our space that is effectively a slice of those underlying physical disks, the Windows Server storage engines will actually handle the movement of hot data to the SSDs for increased performance and the cold data to the hard disk drives for obviously taking advantage of the higher capacity.
Sorry, hot data, cold data, let's just define that.
So if you imagine blocks of data making up a VM or whatever it may be, a workload, there's data that's going to be being accessed all the time.
Maybe
it's
a
going to
SQL database memory.
Yeah, but down to the block level. And they're going to be moved to the SSD tier where they're going to sit on SSD and the performance is going to really be rapid. Whereas some of the stuff that's not being used at that time, perhaps a certain VM that's idle has got a lot of blocks that aren't necessarily busy, we can move that to the cold data. Your virtual disk is still residing on the storage space, it's just we're moving the blocks of data to reside on different tiers.
It's kind of almost like memory, right? Memory on a computer, right? You load what's active that you're using, the memory that's not active, you kind of deprovision it. So you could kind of think of this storage architecture as an equivalent to what we're doing with memory management as well. Keeping what we're using regularly loaded, and pushing out what we're no longer using, what we're no longer keeping active.
Yeah, good point. Yeah, exactly right. And when we think about managing all of this, which is important, Virtual Machine Manager gives us a great platform to manage these key components. So for instance, it allows us to manage the file server storage, so that SMB file server. So we can bring in that file server by name or by IP address, and this isn't just a file server from a Microsoft perspective. There are other storage vendors out there that are supporting SMB3, like NetApp, like EMC. There's others coming available more and more as we go forward as well. And VMM supports integration and management not only of the single file servers, but also clustered file servers as well. In fact, it can even be used to create clustered file servers. So it will quickly discover and inventory the file server storage, very consistent wizard with what we saw before with the iSCSI, and then we can classify our tiers, our file shares that we found. Or we can use VMM to actually create those file shares as well. And the beauty of VMM and using VMM for this is I can use VMM to assign file shares to specific Hyper-V hosts. It will handle all of the ACLing, all of the permissions for me without me needing to do anything special, really, which is very, very useful. So, we've kind of touched on scale-out file server, we've touched on what that's all about, using that JBOD storage, using clustered pools and spaces, and using multiple file server nodes for resiliency scale-out. So if one dies, the connectivity will stay to the other file servers. So we're providing a more resilient, more high level of availability. It's active file shares, so they're always online, and as you add more scale-out file server nodes, we increase the bandwidth that's available. And as I said before, this can be created by you and inherited into VMM, or VMM can create this scale-out file server for you from an existing Windows server or set of Windows servers, or from bare metal, like we talked about the bare metal deployment of Hyper-V earlier. VMM can also deploy scale-out file servers.
So I just want to kind of clarify what we mean by active-active in the state of a cluster. What that basically means is we have 2 or more nodes that have that client access point running on it. And so for the client access point for our file server, that's whack whack my share. Now what we did in the past is you would have that share running on a single host. If that host crashes, that share becomes unavailable, it will fail over, it will come back line on another host. But while that access point is being failed over and moved around, nothing's accessing it. So if we have a virtual machine that's trying to use its VHD on that whack whack my share, that path is no longer accessible. That means we're no longer accessing that virtual hard disk. So what we've done with the scale-out file server is we're now putting whack whack my share on node 1, and on node 2, and on node 3, and on node 4. This way we've kind of scaled that out. We've made it redundant. So if we can no longer connect to my share on node 1 because it's crashed, no problem. We have retry logic built into our protocols. It's going to then go and try whack whack my share on node 2, get reconnected, and there'll be no downtime as it transitions. So just think of this as higher availability to actually access that particular file share itself.
Yep, so rather than sticking slides, I thought we should show some of this stuff.
Let's do it.
Yeah, should we take a look for a little while? Hopefully we can rattle through this quite quickly, because there's a load of host configuration to get through. But what we have on the screen now is our environment. I'm on the VMM server at this point in time, but I'm actually looking in Server Manager. And if you've not seen Server Manager in recent releases, 2012 and onwards, you may see it looks a little bit different. This is the dashboard, and what I'm going to do at the moment, I'm only really managing a single server. But I'm going to right-click all servers, and I'm going to add servers into the mix. I'm going to do a find now, and I'm going to bring in my file server. So I've already got a Windows Server 2012 R2 machine that I want to bring into management of within Server Manager at this point. This isn't VMM. We're not looking at Virtual Machine Manager at this point. Now that I've brought that in, I'll just wait for it to add. There you'll see it's added, and it's got its IP addresses and so on. What I'm going to do is I'm going to look at storage pools, and what you'll see when it refreshes is actually this particular FS01 file server that I've just brought in has got a couple of pools already. It's got pool 1 here, which if you see, if I make this a little bit taller, you'll see it's made up of a number of different physical disks in this bottom right, of which the media type, if I sort by name, you'll see there's a mix of hard disk drives and solid state drives in that pool. And I've already pre-created that. But to do that, I'll show you. I just go new storage pool. We'll go next to read the wizard. We're going to call this one pool 2. I'm going to choose this particular FS01 file server. The physical disks, I'm going to include all of them, and I'm going to mark this last one as a hot spare. So we can let that be automatic if need be, and it's going to handle all of that, but I'm going to do hot spare specifically to mark out this one as a reserved disk in case anything fails across the others. And that, as quick as that, we're able to create a pool. So imagine we've just taken the raw physical disks that have been presented as storage, and we've aggregated them together into a pool. And from that point forward, we can now configure a storage space. And to do that, if I click on pool 2, you'll see it's listed the disks that we've got available. One of them's listed as a hot spare. I'm going to click tasks under virtual disks, new virtual disk, click next. I'm going to choose the pool that I'm going to create this space from. In this case, I'm going to use my tiered pool that I created in advance. Go next, and I'm going to call this one tiered space 1. And I'm going to tick this box to say create storage tiers on this virtual disk. And note at the bottom, I cannot remove tiers after it's created. So this is my one option now to do it. So I'm going to go next. I'm going to choose mirrored layout for resilience. I'm going to go next. And I can choose a 2-way or a 3-way mirror, depending on how many copies of the data you want, to help you protect from multiple disk failures. I'm going to go next. We're going to use fixed provisioning for this virtual disk, for this space, because storage tiers requires that. We'll go next. And for the size, now I could specify a certain size myself. I could say, well, the SSD tier, the fast tier, I want to be 10 gig. The hard disk drive tier, I want to be 6 gig. In this case, I'm just going to go maximum and go next. And with that, we've now created a tiered storage space. Incredibly easy. And you're going to say, well, you've been talking about VMM. Why have you not managed that through VMM? Well, VMM doesn't support creating tiered storage spaces at this point in VMM 2012 R2. So I'm just showing you through the Server Manager wizard. Now that that's finished, I can create a volume. This will make it accessible to the file server, so it will give it like a drive letter, for instance. So I'm going to choose FS01 as the server that I want to create this volume on, and I'm going to choose my tiered space. I'll go next. Now there's a little bug in here that if I leave 4.24 terabytes inside, it's going to say no. But if I change it to gigabytes and use the exact same approach.
It's not a bug, it's a feature.
Sorry, my correct pronunciation, it's a feature.
Maybe a poorly designed one, but...
Yeah, there you go. And I'm going to give this particular volume that I'm creating a drive letter of V. And it's going to go ahead, it's going to format that. I'm going to give it VMs, it's going to format the NTFS, all the kind of default settings you see if you've ever provisioned a drive, which I presume you have, and we'll go create. So you'll see how quickly I've been able to, number one, pool, number two, create a space, and then number three, format the volume. Dead easy.
Now, while this loads, we want to let you guys know there is another poll open. If you're in full screen mode, minimize the full screen mode, scroll down to the bottom of the screen, and let us know what type of enterprise storage you're using. Now, we use this data to just kind of tweak our performance, tweak what we're doing, so it's good feedback if you're answering these questions. Now, if you're also watching live, don't forget, ask us questions. We have an amazing team of Q&A helpers, about 40 of them stacked, ready to answer any of your Microsoft and Microsoft virtualization questions. If you're watching this on demand, then you have missed out on the live event, and well, you're going to miss out on the benefits of the live Q&A, but make sure you come back to the Microsoft Virtual Academy frequently. We're now doing these jump starts very regularly, so sign up and you'll get to go to one of our next live events. Yep,
great. So back in the demonstration, I'm now over in VMM. It's the same machine, it's exactly the same environment. So there's our server manager we've just jumped from. I'm going to drop that down, I'm going to open VMM. And I'm in VMM's fabric view, which, as the name would suggest, allows me to manage the fabric across server storage and networking. And in my storage view here, I'm going to add what's known as a provider. So I'm going to add storage devices here, and you'll see that familiar wizard we saw in the slides earlier. I'm going to select a Windows-based file server as what I want to bring into VMM's management. So I'll go next. I'm going to type fs01.contoso.com. I'm going to choose a run as account. Now, you may have a specific account within your environment to handle this kind of permission. I'm going to create one in VMM. I'm going to call this one, if I can type, storage admin. And under the covers, it's actually just going to use my Contoso administrator account. And the password, there we go, extremely secure. And we'll go OK. And that now has created a specific run as account that I'm going to use for my storage-related tasks. It's a good best practice. That's a kind of silly term. A good best practice. It's a best practice. There you go. And we'll go next. It's going to go away and it's going to search for that particular machine, and there it's found it, FS01. It is a VM in our environment. All of our machines we're working with here are VMs themselves. And we'll select the storage device. It says select file shares to place under management. There's nothing. At this point, we've nothing. Remember, we only just created the volume on that file server, so there's going to be nothing available at this point. So from this perspective, we can just click through relatively quickly. We don't have to do anything at this point. We can just click next and finish. But now, if I click on add storage provider, that's all now completed. We have our file server that's done. So now that we have our file server, if I just click around here just for a second, providers, there we go, and click file share, create file share. This is now from VMM. I'm going to call this one VM share 1. I'm going to create a new classification. Now, classifications in VMM are ways of, as the name would suggest, classifying the storage. So for instance, you may call this one gold tier, silver tier, bronze tier, to reflect the performance. You may have something that's very more specific and technical, like this tier has SSDs backing it, or something like that. But you can include that in the description. I'm just going to call this one gold tier and click add.
Now, one way that we're going to expose these different tiers later is when we start to think about cloud. Now, when we're looking at cloud, remember, we're kind of hiding that underlying infrastructure from our end users. Going back to that case of supporting our SQL database administrator. When that DBA thinks, hey, I want to go provision new storage, they probably don't want to think, well, do I need iSCSI or Fiber Channel, which LUN, which rack? We just want them to have it simplified.
Yeah.
They're just going to pick gold storage. I know I have SQL. I know I need high performance, high IOPS. I'm going to go for the gold tier. So the classifications are useful for both the administrators to just organize things, as well as for our end users to try to simplify the management experience for them too.
Yeah, correct. We finished the file share populating the wizard here. The one thing I've added at the bottom is this local path. This is the local path on the file server itself. So there's going to be a shares repository /VM share 1, and that's going to match my name. I just made that easy. One thing to note, if you've not used VMM before, this view script button is absolutely fantastic. Open it up. That's the exact script to effectively perform what I've just typed into the wizard using PowerShell. So I can take that, I can save it, I can reuse it. Very, very useful. I'm going to close that out and then click Create. And we should see that file share get created. If I click on File Servers, there's VM Share 1. Now, while that's doing that, I'm just going to create another very quickly, VM Share 2. And I'm going to create a new classification called Silver Tier, which, as you can imagine, is slightly less performant than, at least from a classification perspective. And I'm going to give that a local path of VM Share 2. There we go. And you'll see now we've created 2 shares. They're not assigned to any Hyper-V host. They're literally, VMM has created them on the file server. And if I quickly pop over to our file server itself and click on Shares, for FS01, you'll see, if I minimize that to make it easier to view, it's already created them. So it's been effectively performed on that remote server by VMM in this case. So that's creating a share. That's creating file servers and bringing it under management. What about traditional storage? How do we bring that into VMM's management? Well, in this case, we're going to click Providers again, add storage devices. And in this case, I'm going to choose SAN and NAS devices discovered and managed by an SMIS provider. We'll go Next. I'm going to change this to WMI, so you'd have to investigate with your array vendor which one is the most appropriate protocol for you. And I'm going to give the name of our particular iSCSI target. Now, as a non-best practice, this is actually running on our domain controller, so that is an anti-best practice.
It is, for scalability.
Well, yeah, for our lab, yeah, exactly. And we need a run as account that's got permission to perform the query and bring that into management. I'm going to use my storage admin account again, and I'll click Next. And so that's going to go away. It's going to query and discover that particular iSCSI target. And remember, we're just using the Microsoft iSCSI target here, but this could be an iSCSI server from your own storage vendor that you've got within your environment.
Now, I've had a couple of questions come up. What's the difference between iSCSI and SMB? So just want to spend a quick minute clarifying that. Basically, they are just 2 different ways to have remote shared storage. They're both protocols, but they are separate protocols. They both go through the network, through the Ethernet, but again, they're kind of different with what they're doing on the back end. iSCSI you want to think of as a traditional SAN. We connect to this target over the Ethernet, we provision LUNs, and then we manage them as logical units. SMB, on the other hand, is this traditional Windows file server. So we still connect remotely over to a network, but in this case, we're connecting to file shares as opposed to individually carved up LUNs.
Yeah.
Hyper-V fully supported on both, but they are kind of separate in how you're going to manage them at the back end. One is the file server, which we did in the first example, and then one is a more traditional LUN, as we're now doing in this example.
Yeah, that's a good point. Typically, iSCSI storage, you're connecting to block, and SMB, you're connecting to file-based storage.
Great clarification too, yep.
They both use the network, correct, but if you're using multipathing, you would use MPIO with iSCSI, so you would have 2 separate NICs for your iSCSI connection, and you'd use MPIO, as we talked about earlier. If you're using SMB, you can team the SMB NICs, and you can also use a feature that's built into 2012 and 2012 R2 called multi-channel. So you don't need to use MPIO with SMB. iSCSI and MPIO, SMB and multi-channel for resilience. Okay, so we've got that. So back in the demo, it's discovered our storage device, our iSCSI target. So we'll bring that into management, and you'll see we'll tick the box that it's found, so a storage pool that's already existing on that particular iSCSI SAN. And we could apply one of the classifications we've built already, but I'm going to create a new one called, in the spirit of the Olympics, a bronze tier. I didn't think that through, but yeah, it does work. So there's our bronze tier. We'll classify, and we're good to go. So now we've got a pool of iSCSI storage that if a user was deploying a VM and they chose bronze tier, that VM will be deployed onto the iSCSI SAN. If they choose gold, it would go to VMshare 1. If they chose silver, it would go to VMshare 2. Now, obviously, it's important for you as the admin to understand that and not just name them randomly so they don't make any sense. So we can confirm those settings, bring that into management. That's going to take a minute or two to bring that storage array into management. But that, in a nutshell, is how we start to bring in traditional, let's call it quote unquote, storage into VMM's management. Now, once we've done that, we can start to provision some storage on that particular array. So thankfully, that's now completed. So if I click on Arrays, and you'll see I've got my DCO1, misleading that it's a domain controller, but work with me. And I can add capacity. So if I go to my Create Logical Unit, this is me now creating a LUN on that SAN.
Yeah, so just to kind of walk you through those steps again, refresh here, we've gone and we've added that iSCSI target under management. So what that basically means is VMM can go tell that iSCSI target, do something, go provision a LUN, go connect to this particular server. Now that we're managing it, this is the next step. We are actually saying, okay, go carve out that LUN now, go assign it to the different storage. So we're not actually doing it through VMM, we're managing it through VMM, but VMM is then going and telling our actual storage provider, go perform that operation.
Yeah, so if we look in the environment now, you'll see we've got our bronze tier, we've got our iSCSI storage pool that we've classified in that way. If I click on my arrays view on the left-hand side, there's my array. Notice the file server doesn't appear as an array. It's in a separate category called file servers, which helps to organize. But if I click on array, there it is. I can create logical unit, and it's going to say, okay, which pool do you want to create from? So which set of volumes on the array do you want to carve this from? Give it a name. CSV01, a size, in this case I'll just keep it as a gigabyte. And from that point forward I just click OK, and now VMM will talk to the SAN, talk to the iSCSI array in this case, but it could be fiber as well if you were using that, and it will trigger a creation of a LUN on that particular array. And from this point forward, all we're going to do is actually create the storage. We're not going to do anything else at this point in time. We're going to head back to the slides, but hopefully that's giving you an overview of some of the ways that VMM starts to get you started with managing and integrating with both array, traditional, and file-based server storage.
So we got a question saying, what does Microsoft recommend for storage for Hyper-V? Really, we don't have a recommendation. It kind of depends on your needs. As far as simplicity goes, using SMB is a really easy-to-use solution. You probably have file servers already, so quick to set up, low deployment cost. But you're passing the information over your network, so you've got to kind of consider network bandwidth and capabilities there. The other most popular array that we see is using Fiber Channel. Fiber Channel tends to be fast, highly performant, very feature-rich, but it tends to be a little more expensive to deploy. Bottom line, it's fully supported across a variety of different storage interfaces. Use what works best for you. They're all going to work functionally the same with Hyper-V.
Yep. Now, we often get questions around encryption and how I can protect my sensitive data. And thankfully, Windows Server 2012 R2 and even the free Hyper-V server has a feature known as BitLocker. You may have heard of it from having laptops with BitLocker enabled. BitLocker drive encryption is a feature of a server operating system as well, and enables me to encrypt the underlying storage that my virtual machines are hosted on. We don't support BitLocker inside a virtual machine itself, just on the hosts and their drives that they're using to store virtual machines. So for instance, as we've got on the slide here, you'll see a Hyper-V host with some multicolored virtual machines. That's not a feature of Hyper-V, unfortunately, but it helps us to differentiate which virtual disk matches to which VM. And you'll see that there are 4 different types of storage that were attached to this particular one host. We've got a traditional LUN that we've presented to the SAN. We can encrypt that with BitLocker. We've got a virtual disk on storage inside the host itself, on DAS storage. We can encrypt that with BitLocker. We've got a file server where the virtual disk is stored separately. We can run encryption and run BitLocker on that particular file server. And we've got a virtual disk stored on what's known as a cluster shared volume, which you'll learn more about from Simon later on. We can support BitLocker on that as well. So the 4 key places you can place a VM and run it on a Hyper-V host, we can support with BitLocker drive encryption, which is important for certain customers' compliancy needs. Is there a performance hit? Probably a minimal one, just a couple of percentage points to be realistic, but if it's a compliancy need, we build it in the box.
Absolutely. You know, we're seeing more and more actual physical data center thefts. where people are breaking into the data centers and actually stealing storage arrays because they contain credit card information. Very valuable on the black market, but by locking down that physical array with BitLocker, even if someone lifts it out of the data center, still protected. So very important when you're thinking about compliance, especially if you're storing sensitive information on this storage array.
Yep. So now that we're at the end of that kind of storage overview, how does VMware compare with some of this storage stuff? Well, if we think about Hyper-V on the left-hand side, and vSphere Hypervisor there, free hypervisor down the middle, and also Enterprise Plus on the right-hand side, their highest edition. What you'll notice is some of the more advanced capabilities like third-party multipathing, i.e. using the storage vendor's recommended modules to optimize the storage connectivity. You can only do that with the higher editions of vSphere, built in the box with Hyper-V. Offloading the SAN transfer, offloading the SAN capabilities to the SAN, like storage-related capabilities, like a migration or a rapid provisioning. ODX on Hyper-V, VAAI on the VMware world, only in the higher editions of vSphere, not in the free hypervisor. Spaces and vSAN, whilst they both offer storage virtualization-like capabilities, they are different fundamentally in how they operate, but it's out of scope for discussion today. But storage tiering built into Spaces, as we saw, when that mixed pool of SSDs and HDDs, not in the vSphere hypervisor, but it would be part of the vSphere platform with their new flash read cache, which was introduced in 5.5. Network file system support. People often ask, I use NFS for VMware today. What's my alternative for Hyper-V? That would be SMB 3.0. There are pros and cons of both, I'm sure, and we're not going to do a comparison between SMB and NFS, but if you're looking for an apples-to-apples usage comparison, those two protocols will be the same. They're both file-based, both network-based. Dedupe is in the box with Hyper-V, exclusive there, and storage encryption, as we've talked about as well, is in the box. So lots of valuable storage features even in the free edition of Hyper-V. So we've talked about storage. We're now going to look at networking. Many of you will be familiar with NIC teaming. NIC teaming helps us to aggregate physical network adapters, in Hyper-V's case up to 32 network adapters within a single team, aggregates that bandwidth and helps us provide optimal flow and resilience in the event of a problem. There are multiple nodes, switch-dependent, independent, and multiple traffic distribution algorithms in the newer versions of Hyper-V and Windows Server 2012 R2. So NIC teaming is an incredibly easy way now in the box to set up a resilient networking platform for your virtual machines and their virtual machine traffic, if you will. But not just VMs. It's not just with VMs in mind. You may just want to team certain physical network adapters for management or live migration. You wouldn't typically team iSCSI, as we said before, you'd use the MPIO for that, but you could team your SMB NICs for storage. It's up to you. And I've got a really quick demo of actually configuring a NIC team. Should we take a look?
Yeah.
Okay, so let me go back to my
And similar to how we kind of talked about our added level of storage abstraction, where you can really use any underlying storage provider, we kind of do the same thing with NIC teaming now, where we've kind of added our own layer on top. So when you build a NIC team through Windows Server, you don't need to think about the specific programs for this particular NIC, this particular driver, this type of network and interface. You kind of just get a standard way to go build this. Under the covers, we translate that to the specific networking card that we're trying to go and team. So just you manage it from a single place now.
Yeah, and that single place, I'm here in Server Manager again within this environment. Now you're going to say again, well, can't I manage this through VMM? Yes, you can, but in our nested virtualization world that we're using within our lab, the capability isn't quite there. So we're managing it through Server Manager for that specific reason. But in a production environment, when you're creating new vSwitches, as we'll see later on, you can absolutely handle the teaming from VMM in certain scenarios. But here to team certain, I'm going to create some NIC teams on our Hyper-V hosts. Now to do that, I've got to bring my Hyper-V hosts into management. And just like we did before with our file server, I'm going to bring my two Hyper-V machines into management, Hyper-V 01 and 02. And it's going to bring those in, hopefully. We'll see that's in progress. As soon as we get an IP address in this little view here, we should know that we're good to go. Yep, bum, bum, bum. There we go. And now I can right-click one of the hosts, configure NIC teaming, and from there, you'll see online, we've got the network adapters that are available. Maybe I'll make this a bit bigger just to help people see. Loads of NICs in this host. Some of them are dedicated to VMs, some of them heartbeat live migration, management, storage, and so on. I'm going to create a new team. I'm going to call it the incredibly original VM Team 1, and I'm going to select the NICs that I want to add to this team. NIC 1, NIC 2. Additional properties, you'll see I can change the teaming mode and the load balancing mode. They're grayed out for me because some settings are not available for servers running in a guest VM. Okay, so these Hyper-V hosts are nested. So some of these settings, like I was saying and alluding to before, aren't going to work properly.
So I just want to take a step back. You've mentioned nested a few times.
Yes.
Let's just kind of clarify what we mean by nested virtualization here.
Right, nothing to do with birds. Nested virtualization is running a Hyper-V host in a VM on a Hyper-V host.
That's right.
Okay.
We have a fully virtualized lab environment for scalability, and so you're going to see, there are some limitations here. Again, trying to start a VM from within a VM. We can build a VM, we can manage it, but it's actually starting it up that we come across the problem.
So for instance, inside the Hyper-V VM that's running the Hyper-V role, the hypervisor itself won't start. So you couldn't run a VM in a Hyper-V host VM on a Hyper-V host. It just doesn't work in that way. But it allows us to demonstrate a lot of the management capability and control. So we've added our 2 NICs there, so we'll go OK. Now it may pop up a little warning, but I'm not too worried about that in a second. Just take a minute to configure. And while it's doing that, I will pop back to the other machine and I'll do the same on Hyper-V O2. I could have just done it from the same interface, but there you go. Team 1. NIC 1, NIC 2.
So it really is as simple as saying, hey, here's all my networking interfaces, here's the name of the team, here's the 2 that are going to be that team.
Yeah, and if you want to add any additional properties, you can do that as well. But beyond that, it's dead easy. And I can do it all through PowerShell, which makes it repeatable and can scale in that way. So you'll see it's a warning. That will disappear in a few minutes. It says connection pending, but don't worry, when the magic will happen and it will come back online. That's, again, because of that, this nested environment, this Hyper-V and Hyper-V, it just takes a little bit longer from this perspective. But that, in a nutshell, was NIC teaming. Incredibly straightforward. I can close that. In fact, I'll minimize that down now and go back to the slides. Our little animation's going mad here. So if we lose a NIC with NIC teaming, the traffic will just find another way across one of those other NICs. And it's cross-vendor, across 32 up to 32 network teams and network cards in the team. Pretty flexible. Now, to wrap up this networking from a Hyper-V perspective, one of the basic things that people struggle with is the relationship between getting a VM to talk out of the host. They're like, you mentioned vSwitch, you mentioned external switch. What is all that about? It's like jargon. I don't really get it. This will hopefully help illustrate what this is all about. Imagine you've got a Hyper-V host with just one NIC in this case. We'll simplify it. One physical NIC like we've got on the slide here. But there are 3 types of Hyper-V network. First one is private. It's rare that you'll use this beyond lab environments. So is that fair? I would say the same. Very rare to say that. And you'll see BitLocker pop up there. Great. VM1, but we need to make that encryption for security. VM1, VM2 on the slide, running on that Hyper-V host. Private effectively just allows VMs on the same private network to communicate. So VM1, VM2, VM3, VM4, all on the same host. As soon as you move one of those VMs to another host, it can no longer communicate on that same private network. It's a host-specific VM to VM communication mechanism. Okay? If we want the host to have a say in this little connection that's going on, then we create what's called an internal network. And an internal one, if you've ever used a loopback adapter, where you wanted the host to kind of talk to itself, and also if you used it with the virtual server days, it could allow VMs to communicate with the host as well. That's what a loopback adapter will do. Loopback, or this internal network, will create a special NIC on the host to allow it to communicate with VM1 and VM2. But again, this is on a host by host basis. So VM1 and VM2 at the moment, they can communicate with each other, they can communicate with the host, but they cannot communicate with anything outside of that host. Okay? The most common network, however, is external. And external is where VMs can communicate out of the physical port onto the network, and whatever network is plugged into that particular socket or that particular host port. Now, because we only had one physical adapter, if the VMs are using that physical NIC to communicate out, because now it's a vSwitch, how does the host communicate out? Well, normally in a production environment, you'd have other NICs that you would dedicate to management, and we'll talk about that a bit later on. But if you haven't, VMM and Hyper-V enable you to tick a little box that says, allow this host to also communicate out of this network adapter still. Even though VMs are using it, allow the host to do the same. And that's why it creates what we call a host VNIC. So you'll see a vEthernet adapter appear in the network and sharing center within the host, and that is also communicating out of that same physical port. So this 1 gigabit NIC now, in this case, is being communicated via VM1, VM2, and the host out to the network.
And this can, of course, be teamed, right? This
Absolutely, yeah, we could team that. And we're going to actually look at creating a vSwitch shortly. So each VNIC can have multiple VLANs attached to it. If you're using the GUI, only a single VLAN ID can be specified. But if you do want to trunk multiple VLANs to a particular VM VNIC, then you need to use PowerShell. And the PowerShell command is handily presented there for you in the slides. And as I said before, creating an external network, which is the one you will use the vast majority of the time, transforms the chosen NIC that you bind the vSwitch to. It transforms it into a switch, just like a regular switch, and removes the IP address, the TCP/IP stack, from that particular physical adapter. So if you went into Network and Sharing Center, all you would see would be that NIC, that physical adapter, will be listed as enabled, and it would have a vSwitch bound to it. And an optional host VNIC is created, as we said, to allow communication out of that physical network adapter. So they're the basics of it. For the most part, you will be using external physical or external V networks or vSwitches. And when you bind a vSwitch to a physical adapter, what you're actually binding is what's known as a Hyper-V extensible switch. And this was new in 2012, and this effectively provides a lot of granular capability to not only allow VMs to communicate out of that physical adapter via the vSwitch, but it also can be extended because it's an extensible vSwitch, extended by partners and customers. And VMs connect, as the diagram shows, their virtual network adapter to the extensible switch, which handles the traffic through the actual physical adapter. So you can bind the Hyper-V extensible switch to a single NIC, single physical NIC, or you can bind it to a team, and that's what we're going to do shortly. We'll talk about SRAOV a bit later on, but this extensible switch is extensible through partners and customers, and it provides a lot of granular capability for customers as well. PVLANs, ARP and neighbor discovery poisoning protection, DHCP guard protecting against rogue DHCP machines and routers that may be running in VMs, virtual port ACLs to control communication, trunk mode to VMs, i.e. trunking multiple VLANs to a single VM, traffic monitoring, and it's extensible through PowerShell. And if we look at the kind of ways that people are extending, they're typically extending at 4 different levels. So you've got forwarding extensions, filtering extensions, capture extensions. These extensions across NDIS filter drivers, WFP, different scenarios, different filter drivers can plug in at different layers of this particular virtual switch. And maybe a better way of explaining that is through some of the examples of the ways that partners have extended the solution. So not only do you deploy the standard extensible vSwitch, the extendable switch, but our partners plug in with capabilities that extend monitoring capability, like the instance Inmon with their S-Flow product, plugs into a certain layer of the extensible switch and will capture traffic and look at that traffic for further analysis. Five9 Security Manager plugs into the extensible switch, things like the filtering extension. NEC with their OpenFlow PF1000 extensible switch extension plugs into the switch. The Cisco Nexus 1000V, which many of you may be familiar with from the VMware world, plugs into the extensible switch. They don't replace it, they plug in and extend it, which is very different from the VMware world. Common question, can I combine extensions on the same single extensible switch? Yes, you can. That's the whole point. Because of those layers, you can plug in certain extensions at different layers, which is very, very valuable. And when we compare with VMware, Hyper-V in the box, both Hyper-V Server and Windows Server Hyper-V, has a huge number of switch extensions. All of those capabilities built in the box. The PVLANs, the ARP and neighbor discovery snooping protection, DHCP snooping protection, port ACLs. None of those exist in that free vSphere hypervisor. And when we think about the vSphere Enterprise Plus, which is the only SKU that has the distributed switch as part of it, that does enable some of the more advanced networking capabilities. However, some of them are only available when you bolt on an additional vCloud networking and security SKU, which is actually only available now as the vCloud suite, which we touched on in the licensing section earlier, or if you bolt on, for instance, the Cisco Nexus 1000V or the IBM equivalent solution, which is also available for vSphere. So you'll see many of the capabilities there. And when we think about management, VMM handles a lot of that management, that IP address management, that control, enabling you to build things like logical networks, to abstract the detail of your physical network under the cover. And we're going to look at this shortly through some demonstration a bit later on as well. But when we think about bringing in our networks, our VM networks, that's when we'll talk about network virtualization a bit later on. So VMM is managing networking right through the stack, from the top of rack switches, integrating with OMI, through the logical networks, which we'll define later, through the host NICs themselves, applying vSwitches to them, and then the VM networks on top that isolate your virtual machines and their network traffic. So I mentioned top of rack switch integration. Top of rack switch integration uses OMI, a standards-based protocol. For switches running OMI, VMM can communicate, integrate, and allow visibility into those switches in relation to your Hyper-V environment. And in addition, it can automate common network tasks straight from VMM. So VMM can issue commands used through WSMAN, communicating through OMI, the open management infrastructure, enabling us to automate and control much of the switching infrastructure, physical switches here, and integration with VMM. So it helps us to manage that compliancy between VMM, Hyper-V hosts, and the physical switches, ensuring that, for instance, VLAN ports are correctly configured on the switch, on the Hyper-V host, and from a VMM perspective. Just one example there. Now, when we think about logical networks, I touched on it before. A logical network is a way to classify and abstract the underlying physical network. So, for instance, you may have a logical network called management, or Contoso, or live migration. It's a good methodology to actually use and create logical networks that map to your specific network topology within your environment. So like I say, you may have a storage logical network, a live migration logical network, front end, back end, whatever it may be. And these are used to organize and simplify network assignment. And these not only contain the abstraction, but they also contain information about the network sites. So you may have multiple buildings. In this case, you may have multiple floors within the building. Let's just say you've got two buildings. You've got a common logical network that runs across them called Contoso. But within each building, you've got a different subnet. So you may have two sets of sites within the same logical network, and within those sites you may have IP subnets. And we'll go through this in demonstration a bit later on. But what this gives you is the ability to abstract and granularly define the differences between your respective networks within your environment. So you've got two buildings, a single logical network, but multiple sites within those. It supports VLANs, PVLANs, and hosts and host groups can be associated with logical networks. So for instance, if you've got a set of 10 hosts that you want to assign a specific type of storage network to, you can bind those hosts to a particular storage logical network. If you've got a different set of hosts that are using a different set of storage network infrastructure, you could create a logical network that reflects that and bind that to just those 10 hosts. So you can separate logical networks and hosts out to enable you to more easily identify and control and apply policy to those. But we'll go through this in a bit more detail as we see some of the demos as well. And to create a logical network, we'll see some of this in the demonstration easily, but it's a very quick process. Give it a name, identify perhaps some VLANs that are going to exist within that particular logical network and the network sites within that logical network. Give it a name, and it's as quick as that. And from there, VMM can also assign IP addresses and pools. So for the logical network, when it's defining new, say for instance you're deploying a new Hyper-V host, at deployment time, VMM will ask you, do you like to deploy this particular host onto this logical network? And if you choose yes, VMM will also handle the IP addressing scheme of that. It's optional, it doesn't have to, but VMM can manage, as we'll see shortly, the IP address management for a particular logical network as well. So when you're deploying new machines onto this logical network, VMM will deploy the IP addresses onto this particular host or network adapter.
So some people kind of use this like a poor man's DHCP, right? You get to simplify setting up the DHCP server, you get this collection of IP addresses, and essentially it's kind of the same back-end logic. I deploy a VM, I need an IP address. Instead of going to my DHCP server, just take it out of the pool.
Yeah, exactly. Now, not only can it manage the IP addresses and it will assign IP addresses not only to hosts but VMs as well at the appropriate time, but it will also, each IP pool, you can configure gateway, DNS, WINS if you want. So if you're not using DHCP for your Hyper-V host and you're not using the core services that may be available in the broader infrastructure, VMM can actually define a lot of that for you and handle the DNS registration and so on. But then we get into what's known as a logical switch. And a logical switch is a construct that combines a lot of these networking components, and again, we'll see this through demonstration shortly. It combines a lot of these components and pieces and allows you to define a switch that is deployed across multiple hosts and centrally configured and granularly managed. So you remember we talked about the extensible switch earlier on? The logical switch is a more advanced version of that extensible switch, which is centrally configured and granular policies are applied from a VMM perspective. So it allows central management and deployment. And what makes up a logical switch? Well, there are a couple of key constructs, and again, we'll reinforce these through demo because it's quite complex and quite confusing at first. But a logical switch is made up of a couple of constructs. The first one is an uplink port profile. An uplink port profile is something that is applied to a physical network adapter. Okay, you apply it to a physical network adapter or adapters. It will handle the teaming configuration. It will handle any configuration of the physical adapter. So if, for instance, when you're deploying a logical switch, it will ask you which adapters do you want to assign this logical switch to in the host. You'll say VM NIC 1 and 2. And as soon as you click OK, it will assign an uplink port profile to them. And that uplink port profile may contain certain characteristics of the network switch, of the teaming, for instance. It may say, I'm going to choose switch independent or dependent teaming. I'm going to choose a certain load balancing mechanism, depending on what it is. It's up to you, but that's what's contained within the uplink port profile, and that's applied to a physical adapter. You can also create what are called virtual port profiles, and these are like templates for NICs, VNICs, virtual machine network adapters. So imagine the scenario that you want to turn on loads of different Hyper-V virtual network adapter settings. You could go into the VM, open the network adapter properties, tick, 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 lots of boxes, DHCP guard, router guard, etc., and click OK. But if you want to standardize that and deploy that configuration to lots of different VM VNICs, then the virtual NIC profile is the way to do that. The virtual NIC port profile enables me to templatize a NIC configuration. That's the best way to think about it. Apply a NIC template almost. And not only can we apply the template, but we can also classify that with what's known as a port classification. So that might help me to say, for instance, high bandwidth adapter is the classification. But actually what gets deployed to that virtual network adapter is quality of service settings that are a feature of Hyper-V. So we can control and configure all of that from within the Hyper-V, within VMM. And finally, switch extensions. Those are the kind of capabilities that Five9, Cisco, Inmon, those guys are bringing to market. They can also be deployed as part of a logical switch. So rather than me deploy a Hyper-V switch and then go to each individual host and install the Cisco bits or the Five9 bits or whatever, I can incorporate that in to VMM's logical switch configuration and deploy it at deployment time when I deploy that logical switch. It's extremely powerful and centralizes all of the switch configuration into VMM. It also supports compliance and remediation, which means if I've deployed a logical switch to a particular physical host, if somebody tweaks with that host directly at the switch level and it comes out of sync with what VMM believes it should look like, VMM will report that logical switch as out of compliance. Okay, so that's some really useful information about the Hyper-V logical switch. We've gone through port profiles. There's loads of cool stuff in port profiles and virtual port profiles that we're going to explore through demonstration as well. So is it worth ducking into a demo now?
Yeah, why don't we do that? Let's wrap up networking.
Yeah.
And I'll take it from there.
Okay, so if we pop over to my demo environment, let me just log in. There we go. And over in VMM, back where we've been before, so Virtual Machine Manager, what we want to do, because at the moment we haven't really got any hosts imported into VMM, so we need to do that really first. So I'm going to go into my All Host view, and I'm going to add resources, Hyper-V hosts and clusters. And what that's going to do is prompt me with a wizard to bring in my Hyper-V host, because at this stage, VMM isn't aware of these hosts at this point. So I need a run as account to do that. Now I could use one of my existing ones. I'm going to create a new one. It's called VMM admin. And I'm going to mark that as...
Now these run as accounts can be used for a couple of reasons. Basically, it's a template for a service. So when you're deploying a new VM, when you're running a background service, when you're provisioning, or when you're assigning different user roles. You can take advantage of these pre-configured aliases so that each time you don't need to type a username and password, you can just reuse that particular run as account.
Yep. Exactly, and this runner's account has got the appropriate permission to communicate with these particular Hyper-V hosts, of which it's discovered. I'll go next. I'm not going to do anything here. It doesn't need to be placed in a specific host group or any placement path at this point, and I'll go finish. And so that's going to take a minute or two to bring those in. So while that's working away, because we'll need that to finish before. Let me just pop back to the slides and elaborate on just one or two more networking bits, because I'll cover some of these port profiles and stuff when we get back. One of the features that is new in Hyper-V in 2012 and 2012 R2 is something called Dynamic Virtual Machine Queue. And VMQ essentially utilizes the processor and network card that have got VMQ capabilities within it to better process network traffic. So if you imagine a host that's not got VMQ-enabled NICs or capable NICs, the processing of Hyper-V VM network traffic is largely going to be routed to a single CPU, a single core within that CPU, which could get quite hot. Whereas with VMQ, it does a reasonably good job of actually balancing that particular traffic, processing of traffic across a number of cores within that system. However, with dynamic VMQ, we do an even better job of allocating and rebalancing the processing of network traffic along cores in the system. So all this is essentially designed for is to help a more efficient processing of network traffic on the host.
And just to clarify, we do need a networking card that's VMQ capable to take advantage of that.
Of which most modern cards within the last couple of years will have that capability, but certainly worth checking. Now, another hardware-specific capability is something called SRIOV. And SRIOV, everything we've talked about so far has talked about a VMware, a virtual NIC, a VM virtual NIC. And that's what we also term as a synthetic NIC. It's a software-based NIC that Hyper-V creates for the VM inside the virtual network itself, inside the VM itself. And that communicates, as you can see on the slide, through from the virtual machine in the top right, through the Hyper-V extensible switch on the host, and out through the network, physical network adapter onto the rest of the network. However, with SRIOV, we've got this option of, instead of using the synthetic network, the regular network adapter inside a VM, where the traffic would normally flow, instead, we can actually push a virtual function, which is it's kind of like a VNIC that is actually on the physical network adapter that we push into the VM. So it's almost like taking a slice of the SRIOV adapter itself, the physical NIC that you can touch, and putting it into the VM. And what that means is a reduced network latency, reduced CPU utilization for processing traffic, and increasing throughput. It's essentially like binding the physical network adapter to the VM directly. The only difference is multiple VMs can have this functionality simultaneously, depending on how many virtual functions your SRIOV NIC has and contains.
Now, if a customer actually has this capability, do we recommend using it? Is it a best practice?
It depends on the scenario. Good question. If you've got an extremely network-sensitive workload that's generating a huge amount of network traffic, then yeah, it can be very, very beneficial to use SRIOV, but you do require the hardware. Not only the NIC hardware, but your BIOS will probably need to understand it as well. Now, the key consideration as well is this bypasses the Hyper-V extensible switch. We can see from the diagram now, the traffic flow is not going via the extensible switch like it was before, which means you lose any of the benefits of the extensible switch, like the extensions we saw earlier on. And it has to be created at switch creation time. One concern we often have with customers is that, okay, if I turn this SRIOV on, I can understand that I'm going to get blistering performance, but is this machine going to be stuck on this Hyper-V host because it's attached to the physical NIC? And that's not the case. We still support SRIOV and live migration, so we can move that virtual machine to another host. And if that target host doesn't have SRIOV when it lands there, it will just go back to using the synthetic path. If it does, it will get a virtual function from the SRIOV NIC and start using that for its traffic. Okay. That's probably bought us enough time to go back in our host. We can ignore the warning for now with MPIO. I'm not too worried about that. But we have our couple of hosts. Now, they need attention at this point, but we can look into that a bit later on. I'm not too worried about that. I just want to explore the properties at this point. I'll investigate that in our upcoming break.
Well, I believe that needs attention is just saying the recommendation to restart with MPIO, which we can safely ignore.
It could be that, yeah. We can safely ignore for that for now, but I'm going to look into my virtual switch configuration first. We saw some of the host hardware properties earlier on. I'm going to click on virtual switches, And what we see from this wizard is I've got a new virtual switch. I can do logical, or I can do standard. We'll do logical a bit later on, but I'm going to do a new standard switch to begin with, and this is a regular vSwitch. And I'm going to give this a name of vSwitch 1. The external, it's going to be of type external. Remember, we talked about those different options before, and I'm going to bind it to the team.
So this is going to allow this, any VMs that are attached to this virtual switch to go outside of the host and be able to connect back to our main corporate network or any other services.
Correct. And I get a warning saying when it applies, the host may lose temporary network connectivity. That's fine. Not too worried about that for now. You see, it's gone OK now, the host. So that task is running. I'm doing exactly the same on the second machine. It's important to give your vSwitches exactly the same name, because when VMs are live migrating, they're going to want to look for that same network when they cross over. Now remember I said before that VMM and Hyper-V can create a host VNIC if you want to share this physical port with the host operating system. That's that little tick box there, but I'm not going to do that. I'm going to click OK. And that, I think, is going to perform that job. We're pretty much good to go. Yep. So the first one's nearly finished. The second one is pretty much good to go. So now at this point, we could go ahead and we could create some VMs that would use that virtual switch to communicate out to the network. But we're not going to do that for now. Let me pop out back to the slides. The final bit I'm going to touch on before we start to have a break, the network quality of service. If you think about our virtual machines, there's certain VMs that we're going to want to give a consistent level of performance. Maybe we've got an SLA, maybe it's a web-based workload that needs a certain level of performance. Now in that respect, quality of service can be very, very helpful. It helps us to establish both a minimum level of expected service, so I can specify on a VM that it's going to have a minimum bandwidth of 100 meg always available to it, whether it uses it or not. But I can also at the same time say it's got a maximum level of network bandwidth to stop it consuming all of the network within an environment. Now I can do this on an explicit basis, or I can do it on a relative basis, i.e. a weightings type basis. So I can say, well, it's going to be 100 meg explicit, or it's going to have a weight of 1, 2, or 5, and it will balance according to those. So I've got the ability to control that networking performance in a very, very granular way, which I find is very, very useful, and we'll see a bit later on what that looks like. We've touched on port classifications. Again, when we build our logical switch a bit later on, we'll see port classifications a bit later. But port classifications in a nutshell essentially allow us to classify a specific NIC, virtual NIC in this case, to have some kind of performance or certain features. In this case, you can see the whole wizard is this single screen for a port classification. One screen, give it a name, give it a description. That's it. But what this one is doing is allowing us to specify, in this case, high bandwidth DB, and it's a port classification for use with virtual machines that require high bandwidth allocation. Underneath this port classification, when we attach it to a VNIC profile, when we bring those two together, the VNIC profile will reflect the classification. So the settings we made in the VNIC profile may have quality of service enabled. They may have some other specific high performance setting enabled, like maybe SRIOV, for instance. Who knows? How you connect those port classifications and those underlying VNIC profiles, we'll see that a bit later on. Now we're going to go through constructing the logical switch a bit later on, so I don't want to spend too much time on it now. But essentially you just walk through the setup, bringing in the building blocks that we're going to define a bit later. So the port profiles, the switch extensions, the teaming methodology you're going to use when you deploy this particular port profile. All of that gets welded together in this particular logical switch, and once that's deployed, it then takes on all of those different settings and combines those and standardizes them into a single construct, i.e. the logical switch. And for deployment time, all we do is a similar kind of thing that we saw before. We go to our Hyper-V host, we look at the virtual switches option that we saw a little bit earlier, we click new virtual switch, and this time instead of choosing standard switch, we choose logical, and we assign it a particular logical switch and the physical adapters we're going to choose to bind it to. We don't need to handle the teaming because logical switch will do the teaming for us. It will, at least in a non-nested world. And it can also support converged networking. I'll touch on converged networking a bit later when we deploy the logical switch. But it's probably a good time for a break.
I think so. That was a long module, yeah. But we're going to be back in approximately 10 minutes at the top of the hour. So come back, and we will be covering Hyper-V high availability, and then how we actually build and create different virtual machines.
Yep.
We'll see you soon.